Okay, good evening, everyone. I hope my audio and PPT is visible and audible. If any one of you can unmute yourself or write in the chat box, it would be helpful. Okay, yep. Okay, so in the previous class, we had started with tuples. We did not complete it. Today, we will try and complete it. Okay, so again, you can see in the PPT that the first point is that whenever we are creating a tuple, we normally assign values to it, right? So again, you can see that we are creating a tuple called as fruits, and we are having three elements to the tuple, that is apple, banana, and cherry. And whenever we are actually doing this declaration or the initialization, we call it as what? The packing. We are calling it as a packing a tuple. Okay, and obviously, if packing is there, the opposite of it is also very true, and it is called as what? Unpacking, right? Now, again, we have seen this concept in the case of functions, that whenever we are actually returning values from the function, suppose we are returning more than one value. So again, the calling variable, how do we just catch the two values? We take two variables and we just assign the return statement of that function, right? So if we are returning two values, these two variables will catch those values, right? So again, if you remember that whenever we were actually whenever we were actually returning values from the function, it was actually returned in the form of tuples, right? So again, let us see this example. So let us open the command prompt. Let me enlarge this, write Python. And suppose we have a tuple called as fruits, three elements, apple, banana, and cherry, like this. And what do we do next is, suppose we write uh, green, yellow, and red. So we have three variables, and we just assign the name of the tuple, that is called as fruits. Okay. So if I do this, it means what will happen is the first element of the tuple will be assigned to green, the second element of the tuple will be assigned to yellow, and the third element of the tuple will be assigned to what? Red. Okay. So let us see. So if I print green, it is apple. If I print yellow, it is banana, and if I print red, it is cherry. Okay. Also, what happens if, so in this case we have seen that there are three elements, and for these three elements we have seen that we are using actually three variables, right? But it can happen that we are actually using less variables, but the amount of elements are actually higher, right? So in that scenario, let us see what happens. So suppose we add elements into this tuple called as fruits. Now if you remember, how did we add elements to this tuple? So first and foremost, we need to convert this into a list, right? So we'll use the list constructor. We will write fruits. So now L will be a list. So what we will do, we will just append two values. First, let us append strawberry, uh, like this. And then let us append raspberry, like this. Okay. And now if I print L, you can see that there are five elements instead of three. So what we will do now, we will just convert it back into a tuple using the tuple constructor. So we'll write tuple and we will write L, right? So now if I write fruits, you can see that it's a tuple with five elements. Okay. Now let us understand what we can do next. So suppose the number of variables that we are using is less. So in that scenario, let us see what we can do. So here we can write green, so first variable, second variable is for example yellow, and we only have suppose a third variable. We will not use five variables, but we will use three variables for these five elements. Okay. If that is the scenario, what we can do is we can use a asterisk in front of red, for example. Okay. Now what does this mean? Let us understand. So if I write green, yellow, and asterisk red, and if I just write fruits, okay, if I press enter, let us understand what happens. So first and foremost, green will be assigned to apple, yellow will be assigned to banana, right? And lastly, there is only one variable remaining called as red, and there are three elements for this red variable. So what will happen is we will actually create a list, or not we, but the compiler will actually create a list containing three elements: cherry, strawberry, and raspberry, and it will assign that list to the variable called as red. Okay, let us see what happens. So if I print green, you can see we are printing apple. If I print yellow, you can see we are printing banana. But if I print red, you can see that we are printing a list where we have three elements, right? Also, it can happen like this. For example, instead of giving asterisk to red, I can give asterisk to, for example, yellow. And now let us see what happens. So in this scenario, what will happen is green will be assigned to apple, right? We have yellow, but we have a star in front of yellow, right? So again, we will first check that after yellow, how many variables are there. So we can see that there are one variable. So obviously what will happen is that the last value, raspberry, will be assigned to the variable called as red. And all the middle elements that will be left will be taken into a list and it will be assigned to yellow. Okay. If there was another variable after red, then what would have happened? The last two variables would have been assigned to red and the other variable, and the remaining variables would have been assigned to what? Yellow. So in this scenario, let us check what happens. So green will be apple, yes. Red will be raspberry, yes. And yellow, if I say, you can see that it will be a list where we have three elements. Okay. So I hope I'm clear till this. Now, so this is the same thing that we have discussed. Again, whenever we are considering tuple, we can loop through a tuple, right? So what we can do, we can just write for x in fruits like this, and we can give 1, 2, 3, 4 spaces, and we can print what? We can print x. Okay, so what will happen? X will be the iterator, and it will iterate over all the elements of the tuple called as fruits, and it will just take all the elements and it will print it in new lines, right? So if I just press enter, you can see that it is printing them in new lines. Okay. Similarly, we can also use the len and the range functions. Okay. So for that, we can write for x in range len of, for example, fruits. Okay, so len of fruits is actually what? 5. So x will go from 0 till 4, right? So in this scenario, what we can do, we can print using the indexes. So we can write fruits of what? X. Okay, and again you can see that we can do the same thing, right? And since we can use indexes, we can also use the while loop as well. Now if you remember, in the case of while loop, what we did was we actually initialized the iterator first, right? So we can write I equal to 0, and then we can write the condition while I is less than len of fruits, for example. And if it is yes, what we can write, we can print fruits of I, right? And then we can write I plus equal to 1. Okay, like this. And again we can see that we can do the same thing. Okay, now uh, again, if I have two variables or two tuples, we can just use the plus operator to actually add the two tuples, right? So let us say that we have two tuples. So tuple 1 is equal to, for example, uh, A, B, and C, right? And suppose we have a tuple 2 as uh, 1, 2, and 3. Let us change the name, right? Like this. And what we can do is we can write tuple 3 is equal to tuple 1 plus tuple 2. Okay. And now if I print tuple 3, you can see that everything has been added to tuple 3. Okay. All the elements have been added together and they have been assigned to tuple 3. Okay. Now, what else can we do? We can also write, for example, tuple 1. If I print, it was A, B, and C, right? So what we can do is we can just duplicate these elements. So there are 3 elements. We can make it 6 elements by duplicating all the elements, right? So what we can do is we can write tuple 3 is equal to tuple 1 into, for example, 2. Okay. Now if I print tuple 3 like this, you can see that the elements have been duplicated and they have been assigned to what? Tuple 3. Okay. Okay. Next is, okay, these are the two bonus methods that we can use. We can use the count and we can use the index. So let us see an example of that. So suppose I can check that what is the count of the element A in tuple 3. So it should be equal to 2, right? And also I can find out the index of a certain element. So we can write tuple 3 dot index, and we can find A. So you can see it is 0. it should have been 0 and 1, 2, and 3, 0 and 3. But again, the compiler will first check this tuple, and whenever it finds the first instance, it will just return the value. It will not go to the second instance. Okay, so in this scenario, we are actually getting a in the first instance, that is the 0th index. That's the reason why we are printing the 0 index. Okay, now now let us come to the most important question, that why do we use tuples and why not lists? Okay, so again, let us first see the similarities. It would be much more clearer. So you can see that both this are tuples and lists are actually stored to used to store collections of data. They both are heterogeneous in nature, right? So which means they can both store at a single instance of time many data types, different data types, right? Also, they are both ordered, right? Which means the order in which we are uh, putting data into the tuple or a list, and that order is actually maintained. They both are sequential in nature, right? Which means we can iterate over the items that are contained in either a tuple or a list, right? And also, since they are ordered, we can use the index concept. We can use the index concept, right? So we have seen that. Now let us come to the differences. These are actually very important. Tuples are actually what? Immutable in nature, right? So you can see, you have seen earlier, today also we have seen that whenever we want to add elements into a tuple, we cannot do that directly. So first and foremost, we have to convert that into a list, and then after converting that into a list, what we can do is we can append element into the list, and then again using the tuple constructor, we can change the list back into a tuple, right? So we cannot do that directly. We have to first convert it into a list and then do that. Okay. So which means tuples are actually immutable in nature. And again, lists are actually what? Mutable in nature, which means the values of a list can change, but the values of a tuple will never change, right? So this is the main difference between a list and a tuple. Okay. The second difference, let us understand, it is what? Tuples are actually more memory efficient than lists. Okay. Now, how do we calculate this? Let us understand. So let us go to the command prompt. Let us write a small script. So first and foremost, suppose we will import something called a sys, right? We will create a list with 1, 2, 3, 4, 5, 6, 7, and 8, right? Okay. And what we will do is we will just print sys dot get size of L1. Okay. What happened? Okay, I did not write. I did a spelling mistake. So size of L1. Just a second. Oh. Okay, size of L1. What happened? Okay, I actually closed the Python, so I have to re-import it. So import sys, and then let us declare L1, and then what we will do is we will get the size of L1. So it is 120, right? So what we will do next is we will just write L2, and instead of a list, we will say it's a tuple, right? So again, you can see that we are giving the same values, right? 1, 2, 3, 4, 5, 6, 7, and 8, right? No different values, same values, but instead of a list, we are actually giving a tuple. So if I now print the size of L2, you can see that the size is 104. So again, you can see same elements, everything is the same, but again, a list takes more space in the memory compared to a tuple that takes less space in the memory. Okay, so that's the first difference. The second difference is when it comes to time efficiency, again, tuples have a slight advantage over the list, especially when lookup to a value is considered. Okay, so let us again take another example. So we will now import something called as a time it. That's a module to time uh, the execution time of a program. Okay, so what we will do, we will write import time it. Okay, we will just need to write a statement. And what's the statement? Suppose the statement is that we are actually declaring a list with 8 values, 3, 4, 5, 6, 7, and 8, like this. Okay, and what we will do is we will print time it dot time it, and we will just print the timing of the statement command. Okay, so you can see it is 0.798 something. Okay, again, if I just change the statement from a list to a tuple, same element, same everything, just we are converting list to a tuple, and we will print the time. Again, you can see it is taking less time than that was taken by the list to create itself, right? This is the first way that you can do it. The next way is you can write exit here, and you can directly go to your prompt and you can write Python minus m. Minus m is nothing but it's the argument to actually whatever we will give inside the inside the inverted commas, that will be actually considered as a script. Okay, so we can write Python minus m. We can use time it, right? And inside the double quotes, we can write the same thing. L is equal to 1, 2, 3, 4, 5, 6, 7, and 8. Again, you can see it is taking 65 nanoseconds. And if I do the same thing for a tuple, you can see that it is taking uh, just 12 nanoseconds. Okay, so again, uh, tuples are actually very much time efficient when compared to a list. Okay, so I hope the differences and the similarities are clear between a list and a tuple. Okay, now we have completed tuples, so we will move to the next topic, that is sets. Now again, sets as in tuples, lists, and dictionaries are actually used to store what? Multiple items in a single variable, right? And also we have discussed earlier as well that this is set is one of the 4 inbuilt data types in Python. The other 3 being what? Lists, tuples, and dictionaries. Okay. So we have seen lists, we have seen tuples, and we have seen dictionaries as well. And we are seeing the fourth one, that is what? Sets. Okay, now this is the most important thing. If you remember, in the previous class we have said that we have studied list, we have studied dictionaries, we have studied tuples, and every time we have said that these are actually ordered, right? So the question was that if everything is ordered, then why do we need to specify the word ordered, right? Because everything is ordered till now. Whatever we have studied, everything is ordered. So why do we need to specify the word order every time, right? That is because that whenever we are coming to the fourth inbuilt data type in Python, that is sets. Sets are actually what? Unordered in nature, right? Now, what is unordered? If you remember that the order in which we are giving elements into the set, the compiler may or may not keep that order, right? So if I am giving 1, 2, 3, and 4, and if I print that tuple, so it can happen that it will print 4, 3, 2, 1 or 4, 1, 2, 3, whatever the compiler feels like. Okay, so the first thing is it is unordered, and since it is unordered, which means since the place holder of the elements are not fixed, so obviously we cannot use the concept of indexing. So obviously it is unindexed in nature. And also the most important thing is uh, in a set, the collections are actually we have a collection, and in the collection duplicates are actually not allowed. Okay, so this is the most important thing, and we will see that this is the reason why we use sets in our day-to-day programming. Okay, so whenever we are using a set, duplicates are not allowed. So in the case of list, we have seen we can allow duplicates. In the case of dictionaries also, we have seen that we can allow duplicate values but not duplicate keys. In the case of tuples, we have seen that we can allow duplicates, but again in the case of sets, we will see that we will not be able to use duplicate items. Okay, again sets are written with curly brackets, so don't confuse sets with dictionaries. So because dictionary also use a curly bracket, sets also use curly brackets, but the difference is what? In the case of dictionaries, the items are actually in key value pairs, right? But again, in the case of sets, you can see that these are normal items. They are not in key value pairs. Okay. So very quickly, let us create a set. So we can write Python. We can write, we can give a variable name called as this set, and we will use curly brackets. So we can write our famous example, that is apple, banana, and cherry, and cherry like this, right? And if I press enter, and if I print this set, you will be able to see the difference. So you can see that we have given apple, banana, and cherry, but the compiler now has decided to show it as cherry, banana, and apple, right? So it means that the order in which we are giving the elements into the sets, the order is not maintained, right? Also, you can see that since we have given apple, banana, and cherry, this is just printing the opposite, that is cherry, banana, and apple. But that is not the case. It does not print the opposite, because if I have more elements, then you will be able to see that we are actually not printing the opposite, but every time we will print it, the order will be changed every time by the compiler. Okay. Okay, so this is how we declare a tuple, sorry, set. Also, what we can do, we can print the length of a set. So that is the universal thing that we can do. So it should be 3, right? And also we can print the type of set, type of this set. And again, you will be able to see that this belongs to the class called as set. Okay. Now, okay. So again, we can see that a set can have heterogeneous values. So a single set can have strings. A set can have, you can see integers. A set can also have Boolean values like this. Also, a set at the same instance of a time can have a string, can have an integer, can have a Boolean value. Again, can have an integer, can have a string, and so on. Okay. Also, from the Python's perspective, sets are defined as objects with the data type set. So we have seen this. We have seen this example that whenever we print the type of set, it actually shows that it belongs to the class called as sets. Okay. Also, it is possible to use the set constructor. So again, if you remember, in the case of tuples, we have seen that a tuple constructor uses double brackets, round brackets. Also, in the case of sets, we can also see that it uses what, double round brackets. Okay. So again, if you remember, if we write the same thing called as this set, and we write, suppose, set double brackets, we write 1 2 3 4 and 5, 1 2 3 4 and 5 and 6, for example, double bracket close, we press enter, and if we print this set, you can see that it is printing a set. Right. Okay. Now, again, we cannot access items in a set using the index or a key. So we have seen that since they are unordered in nature. But again, if we cannot use the indexes, but still we can use the for loop. Why? Because for loop, we cannot use the concept of indexes. Like we cannot use range and len. Also, we cannot use while loops. But again, we can use normal for loops for actually iterating over the items of a set. Okay, so how can we do that? It's very simple. We can just write for x in this set like this, right? And we can print x. Sorry, like this. Okay, right. Also, we can use the in keyword. So which means if I can write if, for example, 3 in this set. So what we can do, we can print yes, for example. So again, you can see we are actually printing yes using the in keyword that we have in Python. Okay. Now, okay. Again, to add items into a set, we can use the add method. So let us do one thing. We have this set like this. So what we can do is we can write this set dot add. Let us add a string called as orange like this. And now if I print this set, you can see that the thing has been added. Also, let us try and add a duplicate value. Okay, let us see what happens. So 2 is already there. Let us add 2 once. Okay, and if I print this set now, sorry, what happened? Okay, this set, you can see we added 2, but the 2 is not showing here because the 2 was already present, which means a set will not allow for duplicate values. Okay. Okay. Also, we can use the update method. Now, what is the update method? Let us understand. So, suppose we have a set called as, so this is this set. Let us say set 2. And suppose we say that we have A, we have B, and suppose we have C. Okay. Uh, right, like this. Okay. Now, what we can do is we can write this set dot update, and we can give the name of the set 2 like this. Okay. So again, when I'm pressing enter, you can see that there is no output coming, which means a new set is not created, right? So if I write this set dot update of set 2, if there is no output, if I press enter, it means a new set is not created. So what does this mean actually? It means that the values of set 2 are are actually added into the set 1 actually, or this set in our example. Okay, so if I print this set now, you can see that the elements have been added, A, B, and C. Okay, so this is the important thing, because we will need it later. That whenever I'm using the update method, it means a new set is not created actually. What is happening? The elements of the new set is being transferred into the elements, transferred alongside the elements of the old set. Okay, so whenever we use the update method, a new set is not created. So why I am laying emphasis on this, because we will need this thing later in our class. Okay, now, okay, not only can we add sets, or we can update sets, but using the update method we can update many other things as well. So suppose, let us say we have a list, and in this list suppose we have AA, BB, and CC, for example. So any iterable we can add into a set using the update method. So let us say we are writing this set dot update of, for example, L, and if I print this set now, you can see that these things have also been added into the set. Okay, now, okay, so again we can remove elements from a set using two methods. Same method, both do actually the same thing, the remove and the discard, and let us see how. So let us first remove the AA, right? So we can write this set dot remove, for example, AA, like this. And now if I print this set, you can see that AA has been removed. Also we can use not the remove but another method called as discard, like this. And instead of AA we can write BB, and again if I print this set, you can see that the BB has been removed. Okay, so both the things do the same thing. Okay, the next thing is we can also use the pop method. Now what is the use of a pop method? Pop method will always delete the last element. Okay, so by principle the last element is orange, so it should delete orange, right? So let us write this set dot pop, like this. If I press enter, you can see it has actually deleted the one, right? So what is happening actually? So whenever we were printing this set, we printed the last element as orange, but whenever this thing was compiled, the compiler found out that in the set the last element at that time was one, so it has popped out one. So again you can see that it is actually unordered in nature, right? Okay, the next thing is we can use the clear method to clear elements of a set, and also we can use the del method to actually delete the whole set altogether. Okay, so let us see. So if I write this set dot clear, like this, and now if I print this set, so you can see that it is an empty set. Okay, and lastly we can delete, using the del keyword we can delete this set altogether. So now if I print this set, you can see that it will give an error because this set is not there in the memory anymore. Okay, right. Let's move forward. So again we can use okay, we have already done this. This is here by mistake. Okay, so you can use the union method, and you can use the update method. So let us now understand what is the function of a union method and what's the function of a update method. Okay, so let us say that we have two sets. One is set 1, and here suppose we have 1, 2, and 3, and suppose we have set 2, and here suppose we have A, B, and C, like this. Okay, now what we can do, what is union? Union is nothing but we will actually add elements of both the sets, right? And again, what is update? We have seen earlier that we will actually add elements of both the sets. Okay, but let us first do the union, and we will understand the difference between union and update. Okay, so if I write set 1 dot union set 2, if I press enter, you can see that there is a new variable. What happened? Okay, sorry. If I press enter, you can see that there is a output coming, which means using this statement, we are actually creating a new set, right? But again, if you remember, the case with the update method. So instead of union, if I write update, it will do the same thing. The output will be the same. But if I press enter, you can see that there is no output coming, which means actually we are not creating a new set. But what is happening is in set one is being actually updated with the values of set two. So now if I print set one, you can see that the outputs are the same, right? This output and this output, the outputs are the same, but again, the logic is a bit different. So which means whenever we are using the update method, a new set is not being created. And if I don't use the update method, a new set is being created. Okay. Now, if you have understood this, the next part will be easier. So suppose we can have the intersection method as well. Now, what does the intersection method do? It will just, suppose we have two sets like this. So let us define the sets first. So let us say that x equal to apple, banana, and cherry, right? And let us say y is equal to Google, Microsoft, and Apple, for example. Okay. Now, what does intersection do? Intersection will do nothing but it will just take the values that are common between the two sets and it will just keep that value. Okay. So, which means if I just write x dot intersection of y, if I press enter, there is no update. So, which means a new set will be created. So, again, you can see a new set is being created. But again, if I just write the intersection underscore update, so since we have the update keyword like this, a new set will not be created, and instead everything will be updated inside X. So let us see whether that happens or not. So if I press enter, and now if I print X, you can see that actually the same thing is being happening. Okay, the outputs are the same, right? But again, the logic is a bit different. Okay. Also, we can use something called a symmetric difference. So what is symmetric difference? It will just keep the elements that are not present in both the sets. Okay, so it will just keep the uncommon elements that are there in both the sets. But again, we can see that we have two things: symmetric difference update, and we have a normal symmetric difference. So again, if I just copy this, if I just copy this thing, right, and we have a y as this. So what we can do, we can write x dot symmetric difference of what y. So a new set has been created, but if I write update, what will happen? Everything will be updated inside x. So if I print x now, again you can see that both these inputs are actually both the outputs are actually same, but again the logics are actually different. Okay. Okay. Now, why do we need to use sets? So let us move look at the second point first, and we will move look at the first point after that. Okay. So what's the second point? The second point is our Python sets are highly actually very useful when we want to perform common mathematical operations like unions, intersections, and differences. Okay. So we have seen the examples, right? And what's the first thing? The first thing is the Python sets are actually highly useful to efficiently remove what duplicate values from a collection like a list. Okay, so let us have a list, for example. So suppose we have a list, and inside this list, suppose we have duplicate values, right? So suppose let us have duplicate values like this. Okay, and what we can do is we can have a variable called L1. We will use the list constructor. Okay, and inside the list constructor, what we can do, we can use the set constructor as well. Okay, and inside the set constructor, I will give L, and again if I print L1 here, you can see it's a list, but actually now it is having what unique values. Okay, so this is the way that we actually use the set constructor in our daily programming. Okay. Okay, so I will give you a 20-30 seconds breather. All right, till now whatever we have studied, just ponder on that, and let me know that whether you are facing any problems or not. And within this 30 seconds, I will drink some water and I will come back. Okay, so just take 30 seconds of breather, right? Okay, uh, so we are back. Okay, let's now move to a very important topic in Python called as file handling. What is file handling? File handling is an important part in any web application. Python has several functions for creating, reading, updating, and deleting of files, and we will see examples of everything step by step. Okay. Also, the key function, the most important function in the case of file handling in Python, is actually what the open function, and this is the most important thing, and we will see how. Okay, because every time we use files, we will obviously have to use what the open function. This is very important in Python. Okay. Also, the open functions takes two parameters. One is the file name and the mode, right? Now, what are the modes? The modes are actually what? Read mode. So if we are just trying to read a file, right, not write anything into it, we'll use the read mode. We can use the append mode, which means if we have a file and we need to add data into the file, so we can use the append mode. We can use the w mode, which means if we do not have the file and we want to make a file, create a file for writing into it, so we can use the w mode. And lastly, we can also use the x mode, that is just used to create a file if it is not there. Okay, and also it returns an error if the file already exists. So this is the important thing. The X method will actually create a specified file, but again, if the file is already there, it will return what? A error message. Okay. Now, by default, again by default, read is the default value. So if I just mention the file name and if I give R mode, it's fine. If I don't give R mode, then also it's fine because it will by default open it in R mode. Okay, so this is the thing that we need to keep in mind. The second thing, second thing that is default is actually what? In addition, you can specify the file should be handled as a binary or a text file. Okay, so again, we can write T mode, that is for the text file. By default, it is T, which means every file that we will read will be treated as a text file. But what we can do is we can also write B, which means we can just read a file using the binary mode, which means what files can be treated as binary modes. Example, images, these kind of things can be treated as a binary files that we can read using Python. Okay. Now, very quickly, let us go to some examples. So suppose let us exit this Python first. Okay. Let us go to my desktop. Uh, so okay, I was inside users. Okay, so let us go to my desktop and like this. And here we have, suppose we have a file. So we will create a file using notepad.exe. We'll name the file as ec.txt, right? And let us write Institute of Engineering and Management, right? We can write what else? What else we can write? We can write Electronics and Communication, right? Uh, okay, and we can write what? Placement classes, for example, like this. Okay, let us save this. Let us close this. Okay. So we are inside our desktop, right? So from here also we can write Python. So Python will be actually open inside the desktop file path. Okay. And here what we can do is we can write f is equal to open. So if you remember, we have said that open is a very important method, important function in the case of file handling. So we can write open and we can give the file name. So ece.txt. Okay. So either we can use R or by default everything is R, so we also can omit this R. Okay, so if I just press enter, and now if I print the type of F, you can see that it is a IO file, right? Text IO wrapper. Okay, now what we can do now, so if I print F, you can see that we cannot print anything. So again, with this F we need to do some extra thing. So what is that extra thing that we need to do? We can write F dot read. So we are actually telling the compiler to read the contents of the file that is stored in F. Okay, and if I write F dot read, and now if I press enter, you can see that we are printing this. So what is this actually? This is nothing but you can see that it is printing instead of engineering management. That was our first line. Then we are having a new line, right? What is this new line? Because we have pressed the enter, right? So that's a new line. Then we have printed electronics and communication. Again, there's a new line like this. And then we have printed what? Uh, Placement classes. Okay. Also, what we can do is if I just print the type of f dot read, let us see what happens. If I print the type of f dot read like this, you can see it's a string, right? What can we do? We can say that string is a special type of a list, right? So what we can do here is we can also write f dot read like this. Also we can write something like f dot read, and I will whatever I have read, so that's a string. I can use a special thing called a split, right? Now what is split? Which means whatever character I will give inside the split as parameter, so inside the string, if I find that character, I will just split the string by that character. So which means if I just write backslash n like this, which means I will split using this backslash n's, right? So which means first and foremost, I will go and read Institute of Engineering Management, right? Then I will find a backslash n. So I will just omit this backslash n and I will split, which means electronics and communication will now be the second line. Okay. And after I'm reading this, I will find the backslash n. So what I will do, I will just omit this and I will split, which means placement class will now be our third line. Okay. So if I just write f dot read dot split of new line of n, you can see what will happen. What happened? Just a sec. Let us write f dot read. Okay, something happened, which means let us open EC again. So f open ece dot txt like this. Now if I write f dot read, sorry, f dot read, yes, now it is coming. And now if I write f dot read dot split using backslash n like this, what is happening? Okay, I got it. What is happening? Just a second. Save dot read is this. Okay. If I just give double slash, let us see what is happening. Hmm. Okay, actually, it is not taking the new line in Windows. Just a second. Uh, Let me give the R mode like this. And now if I print F, okay, now it is taking. I don't know what was happening. But if I write the same things in a single line, it is now taking. So you can see now it's a list of 3 elements. So the first element is the first line, second element is the second line, and the third element is what? The third line. Okay. Okay. So this is the first thing that we need to understand. The second thing is we can also write. So suppose f dot we want to read only the first 5 characters, for example. So we can write f dot read, and we can write 5 like this. What? Okay, f is now a list. So what we will do is we will just write f equal to open like this, and we can write f dot read of what? 5. Okay. So now you can see that actually it is printing the first five characters. Okay. Also, what we can do, we can take this f, and we can also write something called as f dot read line. So if I just write a read line, which means it will just read the first line. Okay. So if I press enter, you can see that it is printing the first line only, right? Also, what we can do, we can also write f dot read lines. So whenever if I write f dot read lines, again you can see that it will actually read the whole thing. Okay, what happened? Okay, again I will have to reload it. Uh, Again you can see that it is actually printing the whole thing. Okay, so again either we can use the split method, or we can use the read lines method to do the same thing. So whenever I was doing the split method, it was printing the same thing, this thing, right? But it did not print the new lines, right? Because we are splitting using new lines. But if I just read the new lines, it will print the same thing, that is it is printing a list, but again it is not omitting the new lines because we have not split it using the new lines. Okay. Okay, the second thing is what we can do. Okay, so we were inside our desktop path, right? So let me exit this first. Okay, and suppose let us change our path. So let us move into the C drive like this. Okay, and from here if I invoke Python, so what I can do, I can give the file path inside the file name also, right? So I can write f equal to I will write open, and inside this open I will give the file path. So inside C drive, what I had users, right? Double slash, because in Windows single backslash will not work. Double backslash we have to use. In the case of Unix or Linux, we can use single forward slashes, right? But whenever we are using backward slashes, we have to use what? Double backward slashes. So we will write users. We were inside Cynic. We were inside desktop, right? And inside desktop, we had a file called as ec.txt, right? And now if I write f dot read like this, you can see it is printing the same thing. Okay. So these are the initial things that we can do with the help of what? File handling. So we can read files from our any directory that we have in our computer systems. Okay. So I hope it is clear till now. It's 7:23. Let's stop here because I won't be able to complete if I continue later. So in the next class, we will finish file handling. We will also finish the exception handling, right? And also we will see what are actually string formatting. So string formatting is again a very important thing, and we will see how it is done in the case of Python in the next class. Okay. So first and foremost, let me stop the recording.